Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2019, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a, write down the mathematical name of this quadrilateral. Well, you should be able to tell from its single pair of parallel lines that this is a trapezium. B, write down the mathematical name of this solid. It is, of course, a sphere. Question 2, complete this list to show all the factors of 30. Well, factors come in factor pairs, so 1 times 30 is 30, isn't it? So 2 times what is 30? It's 2 times 15. So these two go together as a factor pair. And then our next factor pair is going to be 10 and what? What times 10 is going to be 30? It's going to be 3. So these two go together. And then I've got one more pair to find in the middle. Well, 6 and 5, is it? 5 and 6, I think. 5 goes with 6. 5 times 6 is 30. So again, I've got one more factor pair in the middle. Okay. When I actually do these from a list, and part B says write down the highest common factor, HCF, of 25 and 30. Okay, so we've already worked out all the factor pairs of 30. That's what we did in the first part of the question. Now to answer the next part, finding the highest common factor, the first thing we need to do is find all the factors of 25. And when I do this from the start, I tend to make a little table like this and write down the factors in factor pairs, just like I did a minute ago. So I start with 1. 1 times what is 25? It's 25. And I think, does 2 go into my number? No, it doesn't. Does 3 go into my number? No, it doesn't. Does 4 go into my number? No, it doesn't. Does 5 go into my number? Yes, it does. 5 times what is 25? Well, 5 times itself, isn't it? So actually, 25 doesn't have a lot of factors. It's just got 3, 1, 25, and 5. So the highest common factor then is going to be the largest factor on both lists. So that 5 and that 5 there, look, that's the match. And that is the biggest number on both lists, isn't it? So therefore, the highest common factor of 25 and 30 is going to be 5. Question 3, the line AB is shown on the coordinate grid. Yes, it is. Part A says, write down the coordinates of the point A. Well, the point A is one labelled A up here. And the coordinates are along the corridor up the stairs, aren't they? So 1, 2, 3, 4 along, and 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So this is coordinate 4, 9, isn't it? Okay. Part B, we want the coordinates of B as well. So to get to B, we're going to go 1, 2 to the left, which is -2, and then 1, 2, 3 down, which is -3. So to the left and downwards is negative. So -2, -3, isn't it? Okay, and then part B says plot point C on the grid at 7, -2. Well, 7, -2 is going to be like 7 along, take me to there, and then 2 down. So it's going to be this point here. That's the point C. I'm going to label it C. Let's get rid of that bit. And then part C says the equation of the line AB is y equals 2x plus 1. Okay, a line parallel to AB goes through the point 0, 4. Write down the equation of the parallel line. Okay, well, the point 0, 4 is this point here, isn't it? Okay, and if I was to draw the line parallel to AB, it's quite easy to do on my computer thing because I can just get the gradient to match and then push my ruler up a little bit. You see? Okay, so that's the line parallel to AB going through the point 0, 4. Well, the equation of a straight line can be written in the form y equals mx plus c. And for the original line, m is the gradient, and the gradient is 2. So that's where the 2 goes in there. And the y-intercept of my line is c. So you can see that this line has a gradient of 2. So for every 1 unit you go along, you go 2 up, 1 along, 2 up, 1 along, 2 up. So that's why it's got a gradient of 2. And the y-intercept is 1 because the line passes through the y-axis at the value of 1. Okay, so the equation of this line then is y equals 2x plus 1. Now the parallel line to that has the same gradient. So for every 1 you go along, you're going to go 2 up. So the equation of that line starts out the same way, y equals 2x, because it's got a gradient of 2. But the y-intercept is different. The first line passes through the y-axis at 1. The second line passes through the y-axis at 4. So this is the line y is equal to 2x plus 4. Okay, so that's the line we're looking for. We're looking for the line y equals 2x plus 4. Question 4. A theme park asked 900 people to choose their favourite activity from a list of 5. The pictogram shows the result for 4 of the activities. So we've got thrill rides, family rides, entertainment, children's rides, water rides. And we can see here that this key to this is that like a little grid like this with 4 little cells represents 100 people. Okay, so then how many people chose entertainment? Well, if one of these represents 100 people, look, then in entertainment I've got 2 of those. So that's going to be 2 lots of 100. It's going to be 200. Part 2 says, how many more people chose the water rides than the family rides? Well, the water rides has got 2 whole of one of those grids, and then it's got this other weird one here. So this one, is, this grid is divided up into 4. So if each one of these grid is worth 100, then one of the cells within that grid is going to be 25, then, isn't it? So this is going to be worth 25, 25, 25. I don't think that line should be there. It kind of came out weird when I printed it. So it's actually just 3 of those things. So it's 25, 25, and 25. So that means that one there is worth 75, and that's worth 100, and that's worth 100. So altogether, that's 275, isn't it? Water rides is 275. Family rides, again, I've got 1 whole one, which is worth 100, and one of these quarter parts, which is worth 25. So that's 125. Give me 125 altogether. So how many more people? More means the difference between the 2, doesn't it? So to find out how much more it is, I'm going to have to subtract 1 from the other. So 275 take away 125. That's got a difference of 150, isn't it? So that's 150. 150 more people chose water rides than family rides. And then finally, all 900 people chose one of the 5 activities. complete the pictogram for the children's ride. So the children's ride hasn't been put in there. Okay, so let's just count how many we've got for the other rides. So we already worked out that entertainment was 200. We wrote that down for part A. And then thrill rides we haven't looked at yet, but that's got 100, 100, and 25 and 25. So that makes 100, 150. So that's 250, isn't it? So what we've got all together so far, we've got 250, 125, 200, and 275. That adds up to, well, you can type it into your calculator if you like. I'm just going to quickly do it in my head. 275, 300, 400, 500, 600, 850. So that adds up to 850. So if I then take 850 away from 900, 900 take away 850, that's going to be what's left over for the children's rides. That's 50. So to represent 50, I'm going to have to use half of one of these like little grids, aren't I? So not a whole grid, just like a half of one, like that. Okay, that should do the biz. So that represents 50. If I was in an exam, I'd probably use a ruler to draw those boxes, but you know, it's not so easy on my computery thing, so I'm just going to sketch it in today. Part B says, Will plays a game at the theme park. There are 20 cards numbered 1 through to 20. Will takes a card at random. He wins if the card he chooses shows a prime number. Work out the probability that Will wins. Give your answer as a fraction in its simplest form. Okay, so I think I'm just going to write out all the cards to start with, so I've got them in front of me. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So they're all the possible cards that they can pull out. Now, which one of those are prime numbers? Let's just highlight the primes. So the first prime number is 2, isn't it? 3 is prime, 4 is not prime, 5 is prime, 6, no, 7, no, yes, 8, no, 9, no, because it divides by 3, 10, no, 11, yes, 12, no, 13, yes, 14, no, 15, no, because it divides by 3 and 5, not 16, 17 is prime, not 18, 19 prime. So how many primes are there? So the number of primes altogether then is 1, 2, 3, 4, 5, 6, 7, 8, 8 of those. Okay. Now probability is defined to be successful outcomes divided by total outcomes. Okay. Now the total outcomes here, you've got 20 different numbers that you can pick from. So there is a 20 different possible outcomes when you pick a card. It could be a 1, it could be a 2, it could be a 3, all the way up to 20. Now successful outcomes in this case is the prime numbers, isn't it? So how many primes were there? There were 8. So the probability then of picking a prime number and therefore winning the game is going to be 8 out of 20. Okay. Now don't forget, we need to write it as a fraction in its simplest form. 8 over 20 has common divisors. They're both even numbers, so you can halve them both, can't you? In fact, you can divide both of them by 4, actually. It's better to search for the largest number that you can divide into both. So dividing both of those by 4, I'm going to get 2 out of 5. So he's got a 2 in 5 chance of winning the game. Part C says a family ticket for the theme park costs £68. If the ticket is bought online, it costs 15% less. How much does it cost to buy a family ticket online? Okay, so what we need to do is work out a percentage decrease, don't we? Okay, so I'm going to use my percentage triangle, FOM, stick your thumb on it. Okay, so then FOM, I'm going to try and identify what these are from the question. Okay, now final original multiplier. Final stands for the end price, or what the value is after the percentage change has happened. Okay. Now I don't know what that is. That's actually the one I'm trying to find, isn't it? What the price is after the discount. Okay, so that's the one I'm looking for. Now original is the cost of the ticket before the percentage change. In that case, it's the £68 there, isn't it? So that's 68. And the multiplier, now the multiplier I can get from this bit, it costs 15% less. Now when you're doing percentage change, you always start with 100%. And then if I take off 15%, I'm left with 100 take away 15, that's 85%. But a multiplier is written as a decimal, not as a percentage. Now you can convert percentages to decimals very easily. You just need to divide the number by 100. So 85 divided by 100 is 0.85. I kind of don't do that with a calculator. I just shift the decimal point 2 along. Okay, so my multiplier is 0.85 and my original is 68. Now I want to find the final. So what I do is I cover up the thing I want to find on my triangle. So I cover up the F, stick my thumb on it, and then I'm going to work out what to do with the other two. So those two are on a line, so that means I just need to multiply them together. So final equals original times multiplier. Okay, so in this case, it's my original value, which is £68, times my multiplier of 0.85. 68 times 0.85, what's that, calculator? 68 times by 0.85, that comes out to be 57.8. Now remember, this is money, 57.8, so I can't just write 57.8 as my answer. It's £57.80, isn't it? Okay, you will get marked down for your accuracy if you try and write 0.8 of a pound. Okay, it needs to be in pounds and pence. Question 5, simplify 4a plus 5a minus 7a. And now these terms are all alike, aren't they? They're all to do with a. Okay, so if I start at 4a and I add on 5a, 4 plus 5 is 9, that gives me 9a. And if I then take away 7a, 9 take away 7 is 2, so it leaves me with 2a. Okay, now the second one though, I've got different types of terms here. I've got terms in G, I've got 3g and positive 8g here, and I've also got terms in F. I've got minus 2f and I've got positive 5f. Okay, so if I want to simplify these, I need to collect the like terms together. So the 3g and the 8g added together, that gives me 11g, doesn't it? 11g. 3g and 8g gives me 11g. And then negative 2f plus 5f. There's different ways of thinking about this. You could start at negative 2 on the number line and then add on 5. And then count up 5. 1, 2, 3, 4, 5. Where does that take you to? Minus 2, minus 1, 0, 1, 2, 3. It takes me up to 3. So it's going to give me 3f. Okay, the other way of thinking about it is negative 2f plus 5f is the same thing as 5f. Take away 2f, which is 3f. Okay. Either way, you're going to get 11g plus 3f as your final answer. Question 6, write down the inequalities shown on this number line. Now you see we've got an open circle here at 2 and it's going off to the left. Now, so that means that my x value is going to be strictly less than 2. Now, if this was a filled circle, it would mean that 2 is actually part of the inequality, and I'd have an less than or equal sign here, but I don't, so I haven't. It's just x is less than 2. X is less than 2. Question 7, factorize fully these two expressions. Now, when you factorize an expression like this, what you're looking for is common factors in each term. What's common to each term? Now, what's common to 6 and 9y? Well, 6 is a multiple of 3 and so is 9. So we can say that 3 is a factor of both those terms. So what is common? 3 goes on the outside of your bracket, and what is not common or left over goes on the inside. So 3 times what is 6? 3 times 2 is 6, and 3 times what is 9y? 3 times 3y is 9y. So when you factorize this, you bring out the 3, you're left with 3 lots of 2 plus 3y. Okay. Now, if you're a little bit unsure about your answer, you can then just kind of multiply it out and just double check you've got back what you started with. 3 times 2 is 6. 3 times 3y is 9y. So yeah, it does give me back what I've started. Okay. So it's just a helpful little check that you can do for yourself. Okay. Now, normally when questions say factorize fully, it's a bit of a giveaway that or at least one of the questions has got more than one common factor. If we have a look at the second one, I've got 2x squared and 6x. Now, if I was going to approach it the same way as the last one, I would say, well, look, 2 goes into both my numbers. I could just take 2 out and write it at the front, and that would give me x squared plus 3x inside the bracket. But that would not be correct, or it would only be partially correct. It would only get you one of the marks, because whilst 2 is common to both these terms, they've both got x's in them as well. So 2 is common and x is common. So I should be bringing out 2x, because you have to take out all the common factors and not just one of them. Okay, so bringing out 2x to the front, then 2x times what is 2x squared? Well, 2x times x is 2x squared, and 2x times what is 6x? 2x times 3 is 6x. So it factorizes out to 2x, x plus 3. Now, like I say, if you forget or if you miss one of the factors, so if you just wrote either 2 lots of x squared plus 3x inside the bracket, you would only get 1 mark if you spotted the x, but you didn't spot the 2. So you wrote x, 2x plus 6 inside the bracket, so you factorized out the x, but you didn't do the 2. Then you're going to lose a mark. Both of those answers are only worth 1 mark. The complete answer is 2x, x plus 3. Question 8. Plaza United are playing a football match away from home. Part A says 379 supporters are going to the match by coach. Each coach seats 45 people. What is the smallest number of coaches that will be needed? So to find the number of coaches, all you got to do really is divide the number of people by the size of the coach, don't you? So number of coaches is going to be the number of people, which is 379, divided by the capacity of each coach, which is 45. So calculator, what is 379 divided by 45? Now that comes out to be 8.42 with a dot on the top, so 8.42 reoccurring. I'm just going to round that off to 8.42 for now. But you can't have 0.42 of a coach. You know, you'd only get like the front half and the front wheels, and then it would be cutting a bit in half, and then you would have no rear to it. So that's not going to work, is it? So you can't have 0.42 of a coach. You can have 8 coaches, or you could have 9 coaches. We need to decide which way to round this. Now, strictly, if it was just a number and I told you to round it off, you'd probably go for 8, because 0.42 is closer to 8 than it is to 9. But then you would have not enough space for all of your people. You'd only get 8 lots of 45, 8 times 45, that comes to, you don't have space for 360 people and not 379. So in this case, you have to round it up. So I'm going to say that this is equivalent to 9 coaches in this case. Okay, you have to round it up. Okay, otherwise you're not going to squeeze everybody on. Part B says, in their last 50 matches, Plaza United have drawn 10 matches, lost 5 matches, and won the rest. Sam claims the probability that Plaza United will win this match is 0.7. Show calculations to support Sam's claim. Okay, so if there are 50 matches altogether, you can either win, draw, or lose, can't you? So the number of wins, so number of wins is going to be the total number of games, which is 50, minus the losses, of which there were 5 and 10 draws. So 10 plus 5 comes to 15. So 50 take away 15, that is 35. So they won 35 matches. Now we said earlier that the probability of success is going to be successful outcomes, of which there are 35 wins, divided by total outcomes, of which there are 50 matches. So the probability is 35 over 50. Now if you type that into your calculator, 35, I either use the fraction key or the divide key, 35 divided by 50. You can see that comes out to be 7/10 or 0.7. Okay, so presumably that is how Sam did his maths to come up with this answer, that the probability of a win is 0.7. Now part 2 says, give one reason why Sam's claim may not be reliable. Well, he's made an assumption here, isn't he? He's, you know, if he says he wins 7 out of 10 games, he thinks he's got a 7 chance in 10 of winning this next one. But you know, not every team is the same, is it? You know, if you're playing your local school 11-a-side versus if you're playing Liverpool Football Club, you know, I'm guessing Liverpool Football Club might put up a kind of a stronger match against you. So it's the same here, isn't it? You know, when you're playing a game, it depends on how good your opposition are. If you're playing a weak team, you've got a very good chance of winning. If you're playing a very strong team, you've got less of a chance of winning. So Sam has made an assumption here. Sam has assumed all games have an equal chance of winning, when in fact some teams will be harder to beat than others. Okay. Question 9. Mr. and Mrs. Jones buy cinema tickets for themselves and their 3 children. The cost of an adult ticket is £6 more than the child ticket. The total cost of the 5 tickets was £45. Work out the cost of an adult ticket. Okay, now this does not look like it, but it's actually an algebra question. Okay, because we haven't been given actual numbers, we've been given the relationship between numbers. That tells me that it's going to be an algebra question. And with algebra, we use letters to represent unknown values, don't we? So let's read the question through again. Mr. and Mrs. Jones buy cinema tickets for themselves and their 3 children. The cost of an adult ticket is £6 more than the child ticket. Okay, so what we're going to do is we're going to take the child ticket and we're going to call that X. Okay, so if the child price is X, then the adult price, we were told that the adult price was £6 more than the child price. So if I take the child price and I add on 6, I'm going to get the adult price, aren't I? Okay. So the total cost of the 5 tickets is £45. So we've got Mr. and Mrs. Jones, they're the adults, and then we've got 3 children. So I'm going to have 2 lots of the adult ticket, so 2 lots of X plus 6, and 3 lots of the child ticket, which is 3 lots of X, and then added together, that must be equal to £45. Okay, so what we've done here is we've formed a linear equation in X that we now need to go on and solve. Okay, now I've got some brackets here, so probably a good idea to multiply those out first. So 2 lots of X is 2X. Don't forget to multiply the 6 by 2 as well. 2 times 6 is 12. So I've got 2X plus 12 plus 3X is equal to 45. Okay, so I'm going to collect the like terms together. I've got a term in 2X and a term in 3X. So adding those together, I'm going to get 5X plus 12 equals 45. Okay, so that's looking a little bit more like a straightforward linear equation now. I can try and get X on its own now. The first step is to take 12 away from both sides. Take 12, take 12. Okay, so that one is going to cancel with that. And it's going to leave me with 5X on the left. On the right, 45 take away 12, 35 is 33, isn't it? So 5X equals 33. So then X then is going to be 33 divided by 5, then, isn't it? So what's 33 divided by 5? 33 divided by 5, that comes out to be 6.6, or £6.60, isn't it? Okay, so then the child price is going to be £6.60, and then the adult price is going to be £6 more than that. That's going to be £12.60, then, isn't it? So that's the answer we're looking for. We're looking for £12.60. Now at this point here, you might just want to double check your working and make sure it adds up. So you know, if we just work out what 2 lots of £12.60 is on a calculator, and what 3 lots of £6.60 is on a calculator, and just add those up just to make sure it comes to the right amount. So 2 times 12.6 plus 3 times 6.6, and that should come to 45, and it does. Okay, so that leaves me pretty confident that we've done the right thing. Okay. Question 10, the area of the parallelogram is 4 times the area of the triangle. It doesn't look like it here, does it? But it does say that it's not to scale. Okay, so the area of the parallelogram is 4 times the area of the triangle. Calculate the length L of the parallelogram. So I think the first strategy here is going to be to find the area of the triangle, and whatever that is, we're then going to multiply it by 4, and then we're going to get the area of the parallelogram, aren't we? And once we know the area of the parallelogram, we can work backwards to find the length of the parallelogram. Okay, so let's start off with the area of the triangle. So area of the triangle, what's that then? The area of the triangle formula is half a base height, isn't it? Okay, where the base is this line here, and the height is this one here. Okay, so let's sub those numbers in. That's a half times 4 times 6. Well, half of 4 is 2, and 2 times 6 is 12. So that is going to be 12 centimeters squared. Now, area of parallelogram is simply base times height, isn't it? Because it's just a pushed over rectangle. So in this case, we know what the area is already. It's 4 times the area of the triangle. 4 times 12, that's 48, isn't it? Okay, so 48 is going to be equal to base, which I don't know, but I know is represented by the letter L, times h, which I do know. H is equal to 3. Okay, so subbing that in, so 48 then is going to be, it's basically going to be 3 lots of L, isn't it? L times 3, or 3L. Okay, now to find L then, all I've got to do is divide both sides by 3. That will just leave me with L on its own on the right, and then 48 divided by 3, that's 16, isn't it? So L is 16. Question 11, Harry has a job. On Friday he is paid £8.50 per hour. On Saturday he is paid 1.5 times that rate. He works for 4 hours on Friday. He works for, from 8 a.m. to 1 p.m. on Saturday. How much does Harry earn in total for those 2 days? Okay, so this is going to be a calculation in 2 steps. I'm going to work out Friday's amount first. So on Friday, his wages, his earnings are going to be the number of hours he worked, which was 4, times his pay rate, which was £8.50, wasn't it? So his 4 hours at £8.50, what's that then? So 4 lots of 8.5. 4 times 8.5, that comes out to be 34. So he's earned £34 for Friday. Then on Saturday, his earnings are going to be, well, how much is he earning first off? He's earning 1.5 times his salary. So it's going to be his normal 8.5 hours times by 1.5. I'm just going to multiply it by an extra 1.5 because you get time and a half. Okay. How many hours is it though? From 8 a.m. to 1 p.m. So 8, 9, 10, 11, 12, 1. That's 5 hours, isn't it? So I'm going to multiply through by 5. So the 5 hours times the £8.50, which is a normal rate, multiplied by 1.5, which is the multiplier for his overtime rate for Saturdays. Okay, now you don't need to work out 8.5 times 1.5 first. You can just do it all in one calculation, which is what I'm going to do here because I'm a bit lazy. So 5 times 8.5 times 1.5, that comes out to be £63.75. So 63.75. Okay, so then his total is going to be those two added together, isn't it? The 34 plus the £63.75. So I'm going to add on 34 to my last answer, and that comes out to be £97.75. Okay. Question 12. The volume of a cube is 125 cubic centimeters. Calculate the total surface area of the cube. Give the units of your answer. Okay. Now I've got a cube here, and I know that the volume of that cube, the space inside of that shape, is 125 cubic centimeters. Okay. What size is the cube then? Now with a cube, all the lengths are all the same, aren't they? That's what makes it a cube. If they weren't, it would be a cuboid. So all the lengths are the same. So I'm going to say this is side L, this is going to be side L, and this is going to be side L. Okay, they're all the same. Now the volume of a cube then is going to be those three sides multiplied together. Now with a cuboid, it's length times width times height. But here it's just length times length times length because they're all the same, which is length cubed, isn't it? Okay. So subbing in the value that we know for volume then, 125, that's equal to L cubed. Now what I want is L, isn't it? How do I get L from L cubed? Well, the opposite of cubing something is working out its cube root, isn't it? So if I find the cube root of L cubed, it's going to give me L. But if I cube root the right hand side, I need to cube root the left hand side as well. So what is the cube root of 125? I already know that because I've memorized all my cubes. It's a good idea to do it. If you haven't, you can just type in the cube root button on your calculator. Shift, it's there. Look, cube root of 125, and that comes out to be 5. So I know the length of my cube is 5. So that's half the job. Now I know that it's a cube of side 5. I can go on to work out the surface area. Now the surface area, or the total surface area of a shape, is all of its faces, or work out all the area of all its faces and add them together. Okay. Now, how many faces does a cube have? It has 6 faces. And what shape are each of those faces? Each one of the faces is a square of size L, or 5. Okay, so it's going to be the area of one face, which is 5 times 5, isn't it? Or 5 squared. That would give you the area of one face. But a cube has got 6 identical faces. So if I take that 5 squared and I times it by 6, that's going to give me the total surface area of this shape, isn't it? So 5 squared is 25. 6 lots of 25, I believe, is 150. You might want to check it on a calculator. I think I'm pretty good. And then what are the units? Well, I had centimeters and I multiplied them by centimeters. So that is going to be centimeters squared. All areas measured in square centimeters, even surface area of 3D shapes. So my answer is 150 centimeters squared. Now notice on this answer line there is no unit specified. It does say give the unit of your answer here. They haven't given it for you. Now often they do in questions, but here they didn't. So that means if you don't write it down, you're going to lose a mark. So make sure you write it down. Okay. The other thing to think about, if you have no idea how to find the area in one of these sorts of questions, but it does say give you a unit for your answer, just write down the unit. Is going to get you a mark, even if you get the answer wrong. So if I'd have written down Donald Trump centimeters squared, for instance, I would still get a mark. Okay. because even though the first part of my question is completely all sorts of wrong, the second part, totally fine. So that's what gives you the mark. Question 13, here is a right angled triangle. Show that the angle x is 35 degrees to the nearest degree. Okay. Now, when you've got sides of right angled triangles and angles, then you should know that this is a trigonometry question. And trigonometry questions I use a mnemonic to try and remember all the different various trigonometric ratios, which is a SOHCAHTOA. Okay, is that how you remember it too? Now, so once I've written that down, SOHCAHTOA, then I need to work out what sides have been given, so I can work out which ratio I need to use. Now, the longest side of a triangle is always the hypotenuse, so I tend to label that one first. And then the side that is opposite the angle is the opposite, and the one that joins onto the angle is next to the angle is the adjacent. Okay? Okay, so in this case, I've been given the opposite and I've been given the adjacent. Okay, so which one of my ratios has the opposite and the adjacent in it? Well, it's not SO, because that's got an O and a H, and we don't have H. It's not CA, because that's also got a H. Gotta be TOA. Okay, so now I know that this question involves the tan. So I'm going to write out the full trigonometric ratio for tan. So tan theta is equal to the op over the adj. Now, when you'll remember that. Now, when you're memorizing these ratios, make sure you memorize them with the angles in place, okay, without those thetas in. Because if you don't, then when you try and come and substitute into it, that's where students make mistakes, okay, because they don't know where to put the unknowns in, because they haven't got space for it. Okay, so make sure you remember it, not just as tan equals opposite over adjacent, because you'll lose the placeholder for the angle, and that's important. Okay, so what is the angle here? So the angle here, well, the angle is actually what we want to find. It's the x value, isn't it? So that's where the x goes. So tan x. Now we already know the opposite is the 14, so that goes at the top, and we know the adjacent is the 20. Okay, so tan x is 14 over 20. Okay, now we've got the tangent of the angle and we want the angle itself. Okay, now if you worked out what 14 over 20 is and just thought that was my answer, 14 divided by 20, 0.7, does that angle look like it's going to be a 0.7? Normally angles are like 20 or 30 degrees, and 0.7 would be highly unlikely in a question. Okay, so it's not just dividing one by the other. Remember, you have to use the tan to the minus 1 of the angle of the ratio when you are trying to work backwards. Okay, so if tan x equals 14 over 20, then x, doing the opposite of tan x, is tan to the minus 1. Tan to the minus 1 at 14 over 20. So typing that into your calculator. Now, to access tan to the minus 1 or the inverse tangent, you have to press the shift key first and then the tan key, and that gives you tan to the minus 1 or inverse tan. And then you can write the 14 over 20. I just like to use the fraction key, so I can type it in exactly as on the page. 14 over 20. Mostly closing the bracket is optional, but I think sometimes it isn't, so it's probably a good idea just to make sure you do. And that comes out to be 34.99. Now, I would round off to 3 significant figures normally, so I'm going to write that down as 35.0. 35.0 degrees, because it's an angle. Okay. Oh, we want it to the nearest degree anyway, so that's 35 degrees to the nearest angle. Nearest degree, sorry. Question 14. Dean drives a distance of 760 kilometers in 9 hours. Robert drives a distance of 559 kilometers in 6 hours and 30 minutes. Who has the highest average speed? Show how you decide. Well, when you've got speed, distance, and time, probably we're going to be using the DST triangle, aren't we? Distance, speed, time. Now, if you're struggling to remember which goes which, I kind of remember it goes alphabetically. So D is first in the alphabet, then S, then T. So that's kind of the order that they go into your triangle. So what have we been given and what do we want to find here? So let's do Dean first. So Dean drives a distance of 760 kilometers, isn't he? It's there. So D is 760, and we've been given time of 9 hours. So this is equal to 9 hours. Okay. So we want speed then, don't we? That's the thing that we're trying to find. That's the thing we don't know. So in our triangle, we're going to cover up speed, and then we're going to use the arrangement of the triangle to work out the formula for speed. So speed equals, well, the other two, one is above the other, so it's distance divided by time. Okay, so subbing in 760 kilometers divided by 9 hours. What's that then? Then 760 divided by 9, that comes out to be 84.4 reoccurring. Okay, so I'm going to round it off to 84.4. And then what's the units? So that's going to be, I had kilometers and I divided it by hours, so it's going to be kilometers divided by hours, kilometers per hour. Okay, right, so that's the speed of Dean. What about Robert? Now Robert, he did a distance of 559, there it is there, and he did a time of 6 hours and 30 minutes. So again, distance is 559 kilometers. Speed is what we're looking for. Time is equal to 6 hours 30 minutes. And now 30 minutes is like half an hour. So I'm going to write that down as 6.5 hours. Okay. So then his speed is going to be his distance divided by his time, which is, for him, is 559 divided by 6.5 then, isn't it? So what's that then? 559 divided by 6.5, that comes out to be 86. 86, and again, that is in kilometers per hour. Okay, so who has the average speed? Show how you know, or show how you decide. Well, I've just done all the maths, haven't I? So Robert is fastest because his average speed is 86 kilometers per hour versus Dean, who had 84.4 kilometers per hour. Okay, question 15. Andrew is 165 centimeters tall, correct to the nearest centimeter. Joel is 170 centimeters tall, correct to the nearest 10 centimeters. Show that Andrea could be taller than Joel. Well, look, that makes no sense on the surface, but then when you realize these are rounded numbers, it does kind of make sense a little bit. So Andrea, now we've been told that she is 165 centimeters tall, correct to the nearest centimeter. So when I'm doing these limits of accuracy questions, as is clearly indicated by this sentence here, this tells me it's a limit of accuracy question. What I do is I tend to draw a number line. I mark on the value that I've been given, which is 165. Now in this case, I'm going to the nearest centimeter. So I'm going to go 1 centimeter up, 166, and I'm going to go 1 centimeter down, 164. And then I'm going to think, well, what numbers round to 165? Well, the numbers that are halfway between those or nearer, or halfway between those or nearer, they are the ones that round off to 165, aren't they? So if they're in this area, they're closer to 165 than they are to 164 or 166. Okay, what is the number halfway between 164 and 165? It is 164.5. We call that the lower limit. The upper limit is going to be halfway between 165 and 166. That is 165.5. Okay, I'm going to do the same thing now for the other person, which was Joel. Now Joel, we are told, is 170 centimeters. Okay, so I'm going to put that in the center of my number line. Now we're told this time it's to the nearest 10 centimeters. So if I do the same thing on my scale, I'm not going to go to 171 and 169. I'm going to go 10 up and 10 down because that's how it's been rounded. So 10 up from there is 180. 10 down from there is 160. And again, the numbers that are going to round to 170 are the ones that are going to be halfway between there and there, or halfway between there and there, or nearer. So this range of numbers rounds to 170. Okay, but what is halfway between 160 and 170? That is 165. Oops, I wrote 160 again. Let's do that again. 165, and halfway between 170 and 180, that is 175. Now that means the limits of accuracy for Andrea. Andrea's range or height could be actually anywhere between 164.5 and 165.5, whereas Joel's could be anywhere in the range of 165 to 175.5. Okay. Now let's assume that Joel is down at the bottom end of his possible range, down here. Then Joel could be (165 centimeters), and Andrea could be at the upper end of her range, couldn't she? She could be all the way up here. Okay. Now, strictly speaking, if she was 165.5, she would round up to 166. Well, we can still use it as a boundary. So I'm going to say Andrea could be just under 165.5, which is taller than Joel. Carol makes birthday cards. Each card takes the same amount of time to make. She makes 3 cards in 48 minutes. She has an order for 80 cards. Can she complete this order in 3 days if she works 8 hours each day? Show how you decide. Okay, so I think what we need to do here is to work out how much time it's going to take to create all 80 cards and compare that with the amount of time that she has available. Okay, so up here we know that she can create 3 cards in 48 minutes. So from that we should be able to work out how long it takes to make 1 card. So if 3 cards are in 48 minutes, then 1 card equals 48 divided by 3, which is 16, isn't it? 16 minutes per card. Okay. Okay, and we know she has orders for 80 cards. So the time to make 80 cards, then what's that? That's going to be time for all cards is going to be her 80 cards multiplied by the 16 minutes it takes to make 1 card, then, isn't it? What's that? Now, according to my calculator, 80 times 16, that's 1,280 minutes. Okay, and what's that in hours? I think if we divide it by 60, we should get that in hours, shouldn't we? Which is 21 and 3 recurring, which is 21 and a third, isn't it? What's that in hours and minutes then? You can actually just use this button here to convert it into hours and minutes. I don't know if you knew that, but that's 21 hours and 20 minutes then. Okay, so 21 hours 20 minutes. Okay, and then what do we need to do now? So she can complete this order in 3 days if she works 8 hours a day, or can she complete it? So we've got 3 days, 8 hours a day. So time available that is going to be 3 lots of 8 hours then, isn't it? 8, 16, 24. Pretty sure that's plenty of time. Is that it? Seems to be. No catch. She has plenty of time. So yes, she can, as 24 hours is greater than 21 hours 20 minutes. Question 17. The table below shows the area in square kilometers squared of some countries. Now you can see these areas have been given in standard form. There's a number times the power of 10, isn't it? Write the area of Sweden as an ordinary number. So in the table, Sweden is given as this, 4.5 times 10 to the 5. Okay, so 4.5 times 10 to the 5. If I want to write it as a normal number, I could just type that into the calculator and work it out, or I can work out where the decimal point goes. Times 10 to the 5 will have the effect of shifting the decimal point 1, 2, 3, 4, 5 jumps along. It will go to here, okay, which means there are going to be some extra zeros appearing in here. So my answer is going to actually be 450,000. What's that? That's 450,000, isn't it? Okay. The other way of thinking about it is 10 to the 5 is hundreds of thousands. 10 to the 6 is millions, isn't it? Okay, so that's 450,000. Part B says, which of the countries has the smallest area? Well, the smallest area is going to be the number with the smallest power of 10, isn't it? So if you have looked down those lists, you should know already that Luxembourg is a pretty teeny tiny country, and so is Singapore. So it's going to be out of those two, but if you look, 10 to the 2 is smaller than 10 to the 3. It's definitely Singapore. Singapore is just a teeny tiny island. Part C, Alexa says the area of Australia is approximately 3 times larger than the area of Luxembourg. Is she correct? Show how you decide. Well, just from common sense, I know she is ludicrously wrong. Australia is huge. But anyway, let's look at the maths. So you might think, if she was looking at this, she might be thinking, well, 2.59 times 10 to the 3, which is Luxembourg, isn't it? That's Luxembourg. If you just have a look at the mantissa part, the number at the front, then if you took 2.59 and times it by 3, you would get something around 7.69, which is the mantissa part of Australia. But Australia is 10 to the 6. So that is nowhere close. So Alexis is wrong. And the way you can do that, you can just maybe divide one by the other, can't you? So if you type into your calculator 7.69 times 10 to the 6 divided by 2.59 times 10 to the 3, it will tell you how much bigger one is compared to the other one, won't it? Now, to do that on your calculator, you want to be using the times 10 to the x button down at the bottom here. So when I type in the Australia one, I'm going to type in the mantissa part, 7.69, and then I'm just going to press that key there once. That's going to give me the times 10, and then I'm going to put in the power, which is 6. So 7.69 times 10 to the 6, divide by, then the second mantissa, which is 2.59, and then I'm going to press that 10 to the 6 button again, and I'm going to put in the power, which is 3. Okay, and that comes out to be 2969. So that's equal to 2969 and change. Okay, so Alexis is wrong because Australia is almost 3,000 times bigger than Luxembourg. Okay, you don't have to write equal if you don't want to. Right, so Australia is almost 3,000 times bigger. I didn't write my 3 very well either there. 3,000 times bigger than Luxembourg there. Okay, work out the total area of Russia and Australia. Give your answer in standard form to 2 significant figures. Okay, so I'm going to add these two together. Again, it's a calculated paper, so I'm just going to use the calculator function to do it. So 1.71 times 10 to the 7 plus Australia, which was 7.69 times 10 to the 6. So again, I'm just going to use that calculator button on the for powers for standard form on the calculator. 1.71 times 10 button. Type in the power, which is 7, plus 7.69 times 10 button. Type in the power 6, and that comes out to be 2479.0000. So that's equal to 2479.1234 zeros. Okay. Now, what is that in standard form? What's it in standard form? Okay, so in standard form, the decimal point is currently here. So if I was going to move it between the 2 and the 4, it would go 1, 2, 3, 4, 5, 6, 7 jumps, wouldn't it, over to there? So that means it is 2.479 times 10 to the 7. But that's not 2 significant figures, is it? That's 4 significant figures. So to round it to 2 significant figures, I'm going to round it off after the 4. Next number is a 7, so I'm going to round it up. That makes it 2.5 times 10 to the 7 to 2 significant figures. Okay, so I just rounded it off there. 2.5 times 10 to the 7. Okay. Bob makes dry concrete by mixing cement, sand and stone in the ratio of 1 to 2 to 3 by weight. He buys the cement, sand and stone in bags as shown in this table. So cement is 25 kg and costs £5.50, sand is 20 kg, costs £2, and stone is 15 kg and costs £3.90. He packs the dry concrete into 30 kg bags. Bob buys just enough cement, sand and stone to make 50 bags of dry concrete. Show that Bob buys 500 kilograms of sand. This is quite a lot of info that we need to get through here, isn't it, to get to an answer? Where to start? Well, we've got the ratio of concrete here. It's cement, sand and stone in the ratio of 1 to 2 to 3, isn't it? Okay, so that's going to tell us how many kilograms of each of those things we're going to need in order to make our concrete. Okay, so how much concrete do we need? We want 50 bags of concrete, and each bag of concrete weighs 30 kilograms. So how much concrete is that altogether? So concrete required is equal to 30 times 50. Now with these sorts of questions, it's really easy just to have like a whole page worth of calculations all over the page if you're not careful. And it's really difficult then for the examiner to go and unpick it all and make sure that they award you all the marks. Now what I tend to do is I always kind of show or state what it is I'm finding. Now you don't have to write an essay, but a couple of well-chosen words at the front here, just explaining what it is you're doing, will make your work much more easy to follow for the examiner, and also for you when you come through and check your work a bit later on. Okay, so just get into the habit of kind of stating what it is you're doing for each calculation. It will add wonders to your method. So what's 30 times 50? Reaching for the calculator. 30 times 50, that is 1500. So we want 1500 kilograms of concrete. Okay, that's good. Now, we know the ratio of cement, sand and stone that goes into that concrete. So now we can divide our total amount of concrete into that ratio. So we're going to divide 1500 into ratio 1 to 2 to 3. That's what we're planning to do, isn't it? So how do we do that? Well, we add all the ratios together. 1 plus 2 plus 3 is 6 parts, isn't it? Okay, then we're going to divide our 1500 kilograms into 6 parts. So 1500 divided by 6, and that will tell you how much each part is worth then. So 1500 divided by 6, that comes out to be 250. So 250 for each of those parts then, isn't it? So that means we can take the ratio of 1 to 2 to 3 and we can scale it up then by a factor of 250. So that means we need, so the first one, remember, was cement, and then it was sand, and then it was stone, which annoyingly is the same initial as sand, but anyway. So one lot of 250 is 250, two lots of 250, that's 500, and three lots of 250, that is 750. Okay, so that means we need 250 kilograms of cement, 500 kilograms of sand, and 750 kilograms of stone. Okay, so we've kind of done what we needed to do then, haven't we? So sand is this one here, it's 500. So I can just say, therefore, we require 500 kg of sand. Part B says Bob sells the 50 bags of dry concrete for a total of £396. Calculate Bob's percentage profit. Well, his profit is going to be his income, which is going to be the £396, minus his expenditure, how much he spent on buying the stuff to start with. Okay, so we know his income already, it's 396, but we don't know the outgoings yet because we haven't calculated it. So that's the first job we need to do. Now, if you remember from the first part of the question, we worked out that we required 250 kg of cement, we needed 500 kg of sand, and we needed 750 kg of stone. Okay, so from that we can work out how many bags we needed for each of these then. So 250, so if you remember, cement comes in 25 kg bags, so if we need 250 kg, then 25 divided by, 250 divided by 25 is going to be 10 bags, isn't it? So we're going to need to multiply £5.50 by 10. For 500 kilograms of sand, if it comes in 20 kilogram bags, how much is that then? That's 5 bags is 100, so 500 would be 25 bags. So we need 25 of those. And 750 kilograms of stone in 15 kilogram bags. So how many times does 15 go into 75? 15, 30, 45, 60, 75 goes in 5 times. So I think that's 50 bags then, isn't it? Times 50. You can just use a calculator if you're not sure how I did those. So then we're going to multiply those together then to work out how much is the cost of each of these things. Cement, that is going to be £5.50 times 10, which is, well, it's just £55, isn't it? Sand, that's going to be £2 times 225, so that's going to be £50. And stone, that's going to be £3.90 times 50. Well, times 100 would be 39, wouldn't it? 300, no, it would be 390. And then half of that for 50, half of 390. Ugh, maths. 200, 195, 195. Okay, so that costs 195. Adding all that up, I suppose I could just do this on a calculator, but I try and do things in my head when I can. 105 and 195, that costs 300 altogether, doesn't it? Okay, so what's his profit? So profit is going to be income minus expenditure, which is going to be his £396 he had come in, what he sold it for, and the £300 that he sent. That is a profit of £96. But remember, we need it as a percentage. Now you can find percentage profit by taking his profit and dividing it by his expenditure, and then turning that into a percentage. So that's going to be 96 over 300, which I believe 96 divided by 300, that comes out to be 0.32 as a decimal. And that as a percentage is going to be 32%. Another way of thinking about it is income divided by expenditure and then subtract 100. That's another way of doing it. But anyway, answer is 32%. 12 students take 2 tests. Each test is out of 60. The scatter diagram shows the results for 10 students. Okay, so we've got 10 out of the 12 students already plotted on the scatter graph, and the first part of the question gives us the 2 extra students that we need to plot. Okay, so you can treat these as coordinates. So the 11th student that we need to add on got 36 in test 1 and 44 in test 2. So that's all we need to do is find 36 along test 1. So what we've got here, we've got like 10 little squares between 0 and 10, so each square is worth 1. Nice and easy scale. So 36 is going to be here. And then 44, same scale on the other axes. It's going to be there. Okay, so I've plotted the 36 and the 44. Next one, 38 and 41. 38, 41. It's going to be there. Now, part B wants us to describe the type of correlation we have here. This is nice and straightforward. Look, we've got a clear upward trend going on here. If I was going to draw a line of best fit on, it would look something like that, which is definitely sloping upwards, isn't it? So this, I would say, is strong positive correlation. It's positive because the line is sloping upwards from left to right, and it's positive, strong because the points are all pretty close to that line. Okay, we haven't got any massive outliers or anything, so I'm going to say that this is strong positive correlation. Okay, strong positive correlation. Now the last part says draw a line of best fit, which I kind of already did, and it says another student was absent for test 2 and the student scored 40 marks on test 1. Use your line of best fit to estimate a result for this student on test 2. Now that's really easy to do once you've got your line of best fit drawn. All you've got to do is read up from the value that you've been given. So I think we've been told they got 40 marks on test 1. So reading up from 40 on test 1 until we hit our line of best fit. Okay, when we hit line of best fit, we change direction. Go the opposite way. You can see that comes out here on my graph, which is about 43. Okay, so that's what I'm going to estimate then. I'm going to estimate that as 43 marks. Part D says work out the percentage of the 12 students whose result on test 1 is lower than their result on test 2. So they did worse on test 1 than they did on test 2. Okay, now coming back to the graph, if I draw on a line on here that shows when they did exactly the same, so if they did exactly the same, then they're going to lie on this diagonal line then, aren't they? That goes through 0, 0, 10, 10, 20, 20, 30, 30, 40, 40, and so on. So this line, if I do a kind of a diagonal line, dotted line up here, this line here represents them doing equally well. So if they're above this line, they're going to do better on test 2 than they did on test 1. And if they're below this line, they're going to do better on test 1 than on test 2. So we want the points that lie above the line then. So how many are there? Let's just go through and ring them. There's that one, 1. There's that one, 2. There's that one we draw 3, that one other one we drew 4, and that one there 5. So actually there's 5 of them altogether that lie above that diagonal line. Okay, out of 12, so we want to work out what 5 out of 12 is as a percentage. So I'm going to write down 5 students did better on test 2. So they're the 5 we want. So 5 over 12 is a percentage. All we've got to do to turn that into percentage is divide it. 5 divided by 12. And as a decimal, that is 41, well, 0.416 reoccurring, isn't it? Which is 41.7 rounded off. So that is 0.417, which is equal to 41.7%. To 3 significant figures because I rounded it off. So my answer is 41.7. Are these two triangles definitely congruent? Give a reason. Now we can see that they look pretty similar and they've got exactly the same angles. I've got 36 and 36, and I've got 80 and I've got 80, and I've got 64 and 64. So they certainly look pretty darn alike. But can I definitely say that they're congruent? Well, we've got several tests for congruence that we know about for triangles, and they have fancy names. One is side, side, side. One is side, angle, side. One is angle, side, angle. And one is RHS. So they're the 4 different tests for congruency that we need to know for GCSE. Now, is this any of these? No, it is not. This is given as angle, angle, angle. Got 3 angles that are the same. That is not one of our tests for congruency. At best, we can say that these two triangles are similar, mathematically similar, because all their angles are equal. Okay, so are these two triangles definitely congruent? No. A is not a condition for congruency. Okay. Right, and then part B says prove that these two triangles are congruent. Okay. Well, here, much easier. I've got an angle that is the same, and I've got that is equal to that, and I know that that is equal to that. Okay. So I think we can show that these are congruent under the SAS rule, side, angle, side. Okay, so in order to prove it, all I need to do is say that angle G is equal to angle J, which was 36 degrees, and I can say that side GH is equal to side JK, which is equal to 9 centimeters, and I can say that side GI is equal to side JL, and that is equal to 7 centimeters. Okay, SAS, side, angle, side, so triangles are congruent. Okay, that's good enough. Okay. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.